what's going on guys? This video is a continuation of my previous logic laws video. You can check my previous video in mathematical foundation playlist. Now let's go ahead and continue this one. Here we are going to talk about trivial laws. The first trivial law is commutative. Commutative is when we have P and Q, we can also write this one as Q and P. And the same goes to OR. When we have P or Q, we can write this one as Q or P. Now let's look at the associativity. P and Q and R, we can write this one as P and Q in the bracket, and then and R. We just replace the bracket to the front one. Now the same thing goes to the OR. It also can be written as P or Q or R. Now let's look at the inverse laws. Inverse law says when we have P or not P, that's always true. When we have P and not P, that's always false. Now let's look at an example of P and not P. For example, if you say it's raining and not raining, it's not going to be true because it cannot be raining and not raining at the same time, because unless some magical thing happen, it's not possible, right? If you find something like that, if it's happening and not happening at the same time, please let me know. But some of you might say like a woman can be angry and not angry at the same time. That might be true, but some smart mathematician has to prove it. Now this is always false and this one is always true. Now let's look at a problem on this one. Show that not P and Q is equivalent to not P and Q. Okay. Before you do this, before you watch this one, you have to know the previous logic laws. If you didn't watch that video, please go ahead and watch that first, and then you will understand. Otherwise it's going to be hard to understand some stuff. Now let's go ahead and start this one. The first thing is we have to write the condition they are asking for. Here the premise is not P and Q and Q. This is called premise, or you can say assumption. Some of you like to write as in the exam paper. If you like that one, just go ahead and write this one, because that's a good way to begin it, right? Now the next thing is we can apply De Morgan's theorem for this one. De Morgan's theorem says when we have not P and Q, it can be written as not P, and this will change into OR and not Q. Okay, and this is for De Morgan's theorem, and outside we just keep it as it is. Each time whenever we apply some laws, we have to always mention what law we did apply. Here we applied De Morgan's theorem, so I put D. The next thing is we can apply distributive law right here. Distributive law says when we have something like this, for example, if you have A plus B times 4, you can multiply 4A plus 4B. You can write it like this, right? That's what distributive law is. You can just think it like multiplying AND with Q and Q with these two. If you do that, this is going to be what we are going to have not P and Q, and we will have OR in the middle, and not Q and Q. This is distributive law. Distributive law. The next thing is we can apply inverse right here. Previously we have seen inverse law that whenever we have something like this, P and not P, that's false. Here Q and not Q, right? So this is false. Not P and Q, and instead of Q and not Q, we can replace that one with false. This is inverse law. Inverse law. And the next thing is we can use the identity law. Identity law says when we have not P and not Q with P, with false, it is equivalent to this one, same as whatever the thing comes with false is going to be just remain the same, like not P, Q. This is identity law. Identity law. I have explained about these laws briefly in my previous video. You can check that one out, and don't forget to subscribe. And if you have any questions, you can comment it below. I will try to answer as soon as possible, and see you next time.